Okay, this is part 2 of the study guide. Sorry that first part got cut off. I'm going to be doing the last, I believe, 8 problems. I believe the first part were the first 7. Before you start part 2 here, make sure you have these changes done on your study guide. Make sure this spot right here, make sure you label that as D prime. And then this spot right here, label that as F prime. I made that mistake when I made the study guide up. So again, instead of F prime right here, that should be a D prime. And instead of a D prime right here, that should be F prime. All right, here we go. So again, I'm going to have you continue to write and check your work, and then write down the last 3 words I was going to have you do. Hopefully you've watched the first part already and gotten credit for those first 3 words. Show me that you wrote it. So here we go. So again, this problem talking about how when you do anything other than a dilation, nothing changes. All the angles will be the same. All the lengths will be the same. Only dilations make lengths change, but even in dilations, the angles are still the same, remember? All right, but again, for this one, knowing that these are just being moved, rotated, and then slid, translated, it's asking you, is angle D more than this angle D right here? Hopefully, again, you've changed that. And again, that is false. Since this angle D and this is really angle D prime, those are the same. So that would be a false statement. Angle F is the same as angle F prime. So remember this angle and then angle F prime, which is really this one, if you label it correctly. Those are the same angle you could see with your eye. That is true. And then length, again, you could see with your eye. This length, DF, is the same as this length, D prime, F prime. You could see that with your eyeball. That is true. But again, when things are just transformed and not a dilation, everything is still the same. The angle is still the same as that. That angle is still the same. That angle up there, E, is still the same as E prime. This length is still the same. All right, next problem. For this one, the 4th word is way. Way is the 4th word. All right, for this one, they want you to do a 180-degree rotation. And you got to remember, when you're doing a 180-degree turn, it's going not just a quarter turn to the next quadrant over, it's going all the way through to the quadrant kind of kitty corner to it. It's going to go all the way over here. Either way I go for a 180-degree rotation. Remember, if it's a quarter turn, you switch the points and make one opposite depending on the direction you're turning. But for a half turn, don't move the numbers around. Leave the numbers the same, but just do the opposite. Just opposite them. So the opposite of -6 is going to be +6. The opposite of 4 is going to be -4. But again, do not switch the points around. You only do that for those quarter turns. Leave the points in the same place, but just opposite them. So opposite of -6, +6. Opposite of 4, -4. Opposite of -3, 3. Opposite of 4, -4. Opposite of -2, 2. Opposite of 2, -2. And then you need to plot those where they need to go. So over 6, down 4. But again, for a 180-degree turn, just opposite them. Don't switch them around. That's only for a 90-degree quarter turn that you switch the points around. So when I plot it, you'll see it's going to be down here. So right 6, down 4 is going to be D prime. Right 3, down 4 is going to be E prime. Right 2, down 2 is going to be F prime. And then going right 7 down 2 is going to be G prime. So you can see that is that turned over when it does that 180-degree turn. It turns over like that. All right. Next problem. And again, 180, it could be either direction, clockwise or counterclockwise. A quarter turn, make sure you know which direction you're going, clockwise or counterclockwise. Quarter turns, it's important. All right, this problem right here. They want you just to understand the two easy transformations to go from this blue to this, or back to this blue. So I want you to realize again, I'm starting with a reflection. I'm reflecting that triangle equal distance on either side of that y-axis, 4 to the left. C prime is going to be 4 dots to the right. B prime is 6 dots to the left. I'm sorry, B prime 6 dots to the right. And you can see when I do that reflection, then I'm just taking that and sliding it or translating it just straight down, not even over and down, just straight down. So these two, it was first reflect, don't say flip, say reflect and tell me the line it's reflecting over. And then it was translated down. Don't say slide, don't say shifted, say translated, and then give me the direction. So reflect across the y-axis, translate 4 units down. Or of course, if you got that backwards and said translate 4 units down and then reflect across the y-axis, you would have got full credit on that one. All right, but again, know you could do it either way. All right, next problem to check. This one, easy. Find the angle next to that 107 degree angle and then add that to 39. So remember, this angle 107 plus this blank angle will add up to be 180. So to find that blank angle right there, take 180 minus 107. And what that gives you is that angle right there next to the red one. That's what it takes to add up to give you 180. So 73 right there. And then once I have that angle inside there, remember the rule. Any external angle on the outside of a triangle formed like that is made up of these two inner angles added up. So this outside angle made up of 73 plus 39. And then of course this angle right here, 107, would be made up of 39 plus whatever this angle is right there. So my high achievers, check that. See that 107 is equal to this 39. And then whatever 180 minus 112 is right there. But again, for this one, back to that. Sorry about that. All you need to do to find this is add up 73 and 39. Add those two up. And that will give you that outside angle, which hopefully you saw was 112. And again, sorry about that. Skipping around. This problem should be a money problem. 112 degrees. All right, the next problem. This one has you understand properties of parallel lines bisected by another. So this, hopefully with your eyeball seeing, you could see all the pairs that are equal. That opening is the same as that little opening. That opening is the same as that. The big opening next to it is equal to this big opening. This big opening over here, G, is the same as this. So hopefully your eyeball can see that. And then know that these are linear pairs. This little opening plus the big one next to it will always add up to be 180. And again, it's easy when they're next to each other, but harder when I'm trying to combine this with a pair over here like D to see that that gets 180. But again, on this, the measures of A and H. All right, the fifth word is 2. 2. All right, the sum of A and H equal 180, and you could see those are the same, so that would be a false statement. Those are the same. There's no way they add up to be 180. And they are kind of vertical, but really vertical has to be right here, but they are kind of in that vertical position. And then A and B add up to give you 180. That would be true. That would be true because again, that pair you could see complete the 180 degree pair. Next problem. B and G are congruent, which is a fancy word for equal in geometry. And you can see, yes, those openings are the same, B and G. That is true. They're definitely not vertical, but they are equal. They're congruent. And then angles E and G are congruent. And again, yes, you could see that opening is the same as that. Yes, they are. That is true. And then angles C and F are vertical, and that is false. The only vertical angle from C is really this H angle. The only angle vertical to F is this A angle. Vertical needs to be straight across. Those two are vertical angles. These two are vertical angles. These are congruent and equal, but not vertical. All right, next problem. Easy one. Know that for this problem, again, your eyeball should be able to see this opening is the same as the one right above it. So if I know this is 73, that angle right here, right away, I know is 73 too. And then all I have to do to find that last angle is subtract that 73 from 180 to get that last pair. So again, these two are congruent. They're equal. So if this is 73, angle B is 73. Right away, I know half my answer here that it's looking for. And then to find A, if I take 180 minus that 73, I'll get what it takes to add to 73 to get that 180. So 180 minus 73 will give me what's left to add to 73 to get 180. So if I subtract that correctly, it gives me 107. And then again, make sure you type those in. Angle B, 73. Angle A is 107. And then know, my high achievers, once you know those angles, you know every single angle in here. You know that's 107. The angle right across from it's 107. If this is 107, you know this one is 107, and this one is 107. 107 congruent. This is 107. Vertical equal congruent 107. This is 73. Vertical 73. These two are congruent equal 73. These are vertical 73. These are vertical 107. Know that. All right. Next problem. Easy. I'm going to have you distribute and combine like terms. You're going to have two more words coming, so make sure you're listening for those two more words. All right, so for this one, distribute first. 4 times x, 4 times negative 3. 4 times x is 4x. 4 times negative 3 is negative 12. And then before you do any inverse operations, combine this 4x and this 6x to give you 10x. So with that 10x minus 12 equal 28, now you could start your inverse operations. You're going to start by adding that 12 to both sides, and then bringing down that 10x, and bringing down your equal, and getting 40 out of this, and then dividing both sides by 10 right there. And then that gives me what my answer is. X is 4. And then again, make sure you type that in that box. All right. The next word is study. Study. And you have one more word coming. All right, this one. They want you to show in words and math why this is a no solution equation right here. So I want you to distribute to get it in that 4x plus 12 look. And then for my high achievers, for all of you, I want you to see that this is a no solution situation. Any number I plug in for x will be timesing by 4, but one side is always going to be adding 12, the other side is always adding 15. There's an impossible situation to get an answer to this. So no solution. So I'd like you to write in words. This has no solution because any number plugged in for x. We'll have one side add 12, and the other side add 15. Again, that situation, I want you to show it with math too. So I'm going to just take any number for x and plug it in. I'm going to use 2 for x, plug it into this form right here. So 4 times 2 plus 12. I'm going to see there's no way that's going to be equal to 4 times 2 plus 15. Because remember, on one side I'm always adding 4 times 2. The other side I'm doing that same 4 times 2. But on one side, after I'm done, I'm adding 12. The other side, when I'm done, I'm adding 15. That will happen every time. This is a no solution. Every number will get this situation. No solution. All right, so show the words. Show me that math. All right, last problem. And one more word coming. This one, I want you to group it and put them in the right place. But because you're smart, I want you to do it by that recognition practice that we were doing. So again, I want you to at least distribute it and get it in that variables on both sides look, or combine like terms like this last one. And then once you have it in that look, again, understand what you're dealing with. This is 3x, this is 3x, this side's adding 6, adding 8. Again, that's that no solution situation there. So I want you to put that equation, either the original or this one, in that no solution box. Because that equation will have no solution. And again, you could have solved that all the way and gotten 0 equal 2, but I don't want you to. Recognize, if it's just asking for solutions, just do that. So that goes right there. All right, the next problem. This has 6x minus 8 equal 4, which technically is plus 0x there. There's really no x's on that side. And again, anytime you have different number of x's on the either side, either x is here, nothing over here, or 0x, that's automatic one solution. Or of course you could have added 8 and gotten 12 divided by 6 and gotten an answer x equals 2 to see that's one solution. Or better yet, different number of x's on either side, or only x's on one side of that equation, always one solution. So 6x minus 8 equals 4 goes in that one solution box. All right, next problem again, without having to solve it. I have x here, same number of x's, but one side I'm subtracting 5 and the other side I'm adding 2. So again, that is that no solution situation. Any number I plug in here is going to subtract 5, add 2. So no way that's going to work. That's a no solution. So that goes right here in this no solution box. And then the one in black, again, variables on both sides. They're different. Automatic one solution. You could solve it. This one a little more difficult. It's going to give you negative 2x equal negative 6, which you'll divide and get positive 3, which is one solution. Or just realize different number of x's on either side, one solution. Know this. You're smart enough to do it this way. So that equation goes in the one solution box. And then the last one. This one has you combine like terms. And then realize what you're dealing with here. Those two are exactly the same. That shows that this is a infinite solution situation. Any number I plug in here is going to be timing by 3 and adding 9. Infinite. The last word is always, always. So just make sure that equation, and I might skip it here at the end, I'm sorry, but make sure this blue equation, either this form or this one, goes in that last box. Make sure to get full credit. You actually put that up there. I might have skipped that. But that goes in the infinite solution box. All right, when you're done, show me the next 1, 2, 3, 4 words that you wrote down and the work, and I will get you off to your next level. All right. Good luck.